Welcome to PJX Resources presentation on the potential of the Vulcan Gold Belt and PJX's gold share property. PJX is a mineral exploration company trading on the Toronto Venture Exchange with the symbol PJX. My name is John Keating. I'm a professional geologist and the president of PJX Resources. This is a standard disclaimer. What you are about to see and hear is based on the best available data that we have. Forward-looking information or statements, including comments about geology, comparisons to types of deposits, or potential discoveries may or may not come to fruition. This map displays gold mining camps in southeastern British Columbia and northern Washington state. The border is located here, between Canada and the USA. Two major structures, the Vulcan Tectonic Zone, shown here, and the Rocky Mountain Trench, located here, are associated with gold deposits and gold mining camps in Canada and the United States. The Vulcan Gold Belt, located here, is the only place in North America where these two major structures intersect one another. Placer gold has been mined from the creeks in the Vulcan Gold Belt here, and here, and here, since gold was first discovered in 1864, and this started a gold rush 2 years after the Caribou Gold Rush. Potential low gold deposits that could be the bedrock source or sources of gold mined from the creeks have not been discovered in the Vulcan Gold Belt. This may be one of the few remaining placer gold mining districts in Canada where the bedrock source or sources of gold have yet to be discovered. For example, Osisko is developing a lode gold deposit in the Caribou Placer Gold mining camp in central British Columbia. So why have lode gold deposits not been discovered in the Vulcan Gold Belt here in southeastern British Columbia? One possible reason could be that when the world-class Sullivan base metal deposit located here was discovered in the late 1890s, the exploration and focus for mining shifted to zinc, lead, and silver. Over 285 million ounces of silver, 8 million tons of zinc, 9 million tons of lead, and other metals in concentrate were produced from the Sullivan deposit. Metals produced from the Sullivan would be valued at over $40 billion in today's metal prices. Caminco was the major mining company that dominated the region for 100 years, until the Sullivan mine closed in 2001 when ore reserves were depleted. Caminco's primary focus was on base metals, not gold. This historical mining district has had very limited drilling for gold. In addition, our current understanding of how gold deposits form is better today than in the past. We, the management of PJX Resources, believe there is significant potential to discover multiple deposits of gold in the Vulcan Gold Belt. The first part of this presentation will focus on gold potential of the Vulcan Gold Belt. The second part will detail the gold potential of just one of PJX's many priority gold targets and why we believe we are close to making a new gold discovery. This table you're seeing shows thermal aureole gold deposits, or also called Pluton-related gold deposits. It was prepared by Vic Wall and Associates and given to us in 2012. Some geologists may call some of these deposits orogenic or sediment-hosted. What you can see from the table is that these deposits occur throughout the world in many different countries. They occur in different geological ages and have a variety of different rock types. One thing they do have all in common, though, is a lot of gold. Here you can see Fort Knox in Alaska, over 5.6 million ounces of gold. Or how about this one, the big one, Muruntau in Uzbekistan, over 100 million ounces of gold. This is Wall and Associates' three-dimensional model showing how these thermal aureole gold type deposits could form. The black dashed lines represent fault structures that penetrate deep in the crust. They form structural zones like this here. And then there are cross structures like this. And where the cross structures or structural zones intersect the other structural zone, there's a weakness in the rock that allows an intrusive to intrude in and form deposits like in this area. Over here, the intrusive, the main body, stays down deeper and fluids and gases come up along structures that form these deposits here. This is Muruntau, granites, Telfer, Obuasi, Sukhoi log. Over here, you can see a bigger intrusive does come to surface, and you get the Fort Knox deposit. And around that, in the other host rocks, you'll get Telfer, Obuasi, and Sukhoi log. You're now looking at a map of southeastern British Columbia. The location map in the upper left-hand corner shows the province of British Columbia, with Vancouver on the west coast, and a square that outlines the location of this map in the southeastern part of the province. The region has excellent infrastructure, with multiple highways, rail, and an airport. The cities of Cranbrook and Kimberley have their roots in mining. Gold was first discovered in Wildhorse Creek in 1864, and this started a gold rush to the region just 2 years after the start of the Caribou Gold Rush. Few records were kept on the amount of gold that was mined. However, anecdotal data suggests that more than 1.5 million ounces of gold have been mined from the creeks. In the late 1800s, the Sullivan deposit was discovered and was mined for over 90 years until it closed in 2001 when ore reserves were depleted. Over 285 million ounces of silver, 8 million tons of zinc, 9 million tons of lead, and other metals were produced from Sullivan concentrates. Metals produced from the Sullivan would be valued at over $40 billion in today's metal prices. Areas in yellow on Wildhorse Creek, Perry Creek, and Moyer Creek represent placer mineral claims that are active today. These placer claims are not owned by PJX. PJX owns bedrock mineral claims and is exploring for the potential lode gold deposits that could be the bedrock source of placer gold found in the creeks. PJX's properties will be presented later. Notice how the three creeks all occur within and along the trend of the broad Kanaswich Vulcan tectonic zone. This is the approximate northern limit of the Vulcan tectonic zone, and here is the approximate southern limit. The gold-bearing creeks also occur where a second major structure called the Rocky Mountain Trench cuts across the Vulcan tectonic zone. We believe that these intersecting structures have influenced the location of potential gold deposits, and this is reflected in the location and orientation of the gold-bearing creeks. The Vulcan tectonic zone represents a wide and long structural zone that is considered to penetrate deep into the Earth's crust and down to the mantle. It was first identified by oil well drilling near Vulcan, Alberta, out in this direction, where the large structural zone was intersected in Archean age rocks that are over 2.5 billion years old. The Vulcan tectonic zone occurring in this age of rocks would be similar to the Destor-Porcupine Fault Zone or Larder-Cadillac Break structural zone that are associated with large gold mining camps in Timmins or Kirkland Lake in Ontario and Noranda or Val-d'Or in Quebec. The tectonic zone can be traced under the Cranbrook area, where it is believed to have influenced the formation of the Sullivan deposit about 1.5 billion years ago. As you can see, the Vulcan tectonic zone has been active throughout geological history. The younger Sheep Creek gold mining camp occurs along the zone here. To the southwest along the zone is the historical Rosin gold and copper mining camp that produced over 2.5 million ounces of gold. Further southwest is the Republic gold mining camp, where Kinross and others have produced about 5 million ounces of gold. The Rocky Mountain Trench is another structural zone that penetrates deep into the Earth's crust. The trench trends north across British Columbia and into the Yukon, where it is called the Tintina Trench and is associated with the Brewery Creek gold deposit. It then continues on into Alaska to the Fort Knox and Pogo gold deposits that each have over 5 million ounces of gold. The only place in North America where these two large, deep penetrating structural zones intersect one another is here at the Vulcan Gold Belt. where 1.5 million ounces of gold are considered to have been mined from the creeks. The next step is to understand the geology of the Vulcan Gold Belt to help discover potential gold deposits that may be the source of placer gold found in the creeks here, here, and here. You're looking at a magnetic geophysical map for the Vulcan Gold Belt. We can use magnetic data to help identify geological features and how they may relate to gold found in the creeks. The red areas represent rocks that are more magnetic, and the blue areas are less magnetic. The large red round magnetic anomaly and smaller ones located here represent intrusive rocks that have come up from depth. The central large intrusive body is shown here. Rows of small intrusives in the Perry Creek and Moyie Creek areas radiate away from the large central intrusive along the trend of the Vulcan tectonic zone. The large red anomaly here may represent a dipping intrusive body that geologists might call a sill. This dipping sill is probably connected to the large central intrusive at depth, and we show this with the dashed lines. We believe that the sill-like intrusive followed pathways created by extension of dipping thrust faults that form the Rocky Mountains in this area. The three placer creeks correlate well with the intrusives. Wild horse placer gold occurs here in the vicinity of this intrusive. Gold in Perry Creek parallels this row of intrusives. And gold in Moyie Creek has a trend similar to these intrusives. When we look more closely at Moyie Creek, we see how all the tributaries on the north side of the creek have gold in them. The scale bar at the bottom of the map shows what 20 kilometers represents on the map. The tributaries with gold occur for over 20 kilometers along Moyie Creek. This suggests that there are multiple bedrock sources for the gold because the tributaries all drain separate areas, which means there is potential to discover multiple gold deposits. To put this in context, the majority of mines in some gold camps, such as Timmins and Kirkland Lake in Ontario, or Val-d'Or in Quebec, occur within a 20-kilometer strike length, similar to the length of Moyie Creek. Remember, this is only one creek drainage. Gold deposit potential also occurs in Perry Creek and the Wild Horse Creek drainages. How does what we've learned compare to Vic Wall & Associates' three-dimensional block model for how thermal oriel gold deposits form? The Vulcan tectonic zone would be similar to this structural zone and penetrate deep into the crust, most likely down to the mantle. The large intrusive occurs where the Rocky Mountain Trench intersects the Vulcan tectonic zone. We believe that the intrusive near surface in Wild Horse Creek connects with the large intrusive at depth, similar to this area. The rows of small intrusives in the Perry Creek and Moyie Creek areas could be the surface expression of a larger intrusive body at depth in this area. According to this model, Fort Knox, Telfer, Obuasi, and Sukhoi log type gold deposits might occur in and around intrusives in the Wild Horse Creek area, whereas Muruntau, Sukhoi log, Telfer, Obuasi, and other types of gold deposits might occur in the Perry Creek and Moyie Creek area. This is the second part of the presentation. Since beginning as an IPO in 2011, PJX has strategically consolidated this large land package covering the potential bedrock sources of placer gold in Wild Horse Creek, Perry Creek, and Moyie Creek in the Vulcan Gold Belt. PJX owns 100% of the mineral rights to 8 properties that represent over 50,000 hectares of land. Large land positions are often required for this type of exploration because you never know where deposits will be discovered. We also have economies of scale. What we learn from exploring one property can be applied to other properties because the properties are all in the same geological environment. Another advantage of working in an existing mining camp is the wealth of historical data. We estimate that over $20 million of historical data is available. While consolidating the properties, we also consolidated this data. identified data gaps, and have been infilling those data gaps with new prospecting, mapping, sampling, trenching, drilling, and modeling to help identify over 20 primary target areas. Gold target areas are shown in yellow dots. Red dots are target areas with silver, zinc, lead, or copper discovery potential. As mentioned earlier, the scale bar at the bottom shows what 20 kilometers represents on the map. A number of our properties are more than 20 kilometers in length. For the remainder of this presentation, we will focus on one target area, the David Gold occurrence on the Gold Shear property, located here. High-grade gold mineralization in the David Zone was found at surface by prospectors in 1990. Drilling by a junior exploration company confirmed the high-grade nature of gold mineralization. No work had been done on the property since the late 1990s, when the gold price collapsed because central banks in Europe sold gold from their stockpiles. PJX made the final share payment in January of this year and now owns 100% of the mineral rights to the Gold Shear property. This display of historical core was provided by previous property owners and was not analyzed by PJX. The two bottom rows, shown here, represent 0.8 meters of core that reportedly grade 196.69 grams per ton or 5.74 ounces per ton gold. The gold occurs with white quartz vein material and black, dark, sooty-looking fine sulfides. The sulfide minerals are a mix of iron pyrite with copper, lead, or zinc sulfides that are locally weakly conductive. Host rocks are sericite clay and or carbonate-altered sediments. This is a geology map for the David Gold Zone that also shows the 9 PJX holes drilled late last year. The David Shear in red trends just east of north. There is also the West Shear and possibly other shears on the property that have not been tested. The David Gold Zone occurs along the David Shear. Our geologists selectively sampled quartz veins to see which contained gold. The red dots are the sample locations. Surprisingly, 8 of the 12 grab samples ran over 68 grams per ton gold. You can see them here and up here. The highest value of 193 grams per ton gold, or about 5.6 ounces gold, is from this area, approximately 150 meters to the north. This sample had 11 visible grains of gold. Now we know that high-grade gold mineralization can occur as visible gold grains, as well as with sulfide minerals, as seen in the historical core in the previous slide. The shears cut across gabbroic rocks in purple and turbiditic sediments in brown. 6 PJX drill holes were drilled in a row, one behind the other, to create what we call offensive holes. This allows us to look at the mineralization and geology in a cross-section. This cross-section shows the offensive holes that PJX drilled across the David Gold Zone last year. You're looking north, so the gabbroic rocks in purple and sediments in yellow and brown dip to the west. There are a series of west-dipping, subparallel quartz veins shown in red. The David Shear Zone, shown here in the center, varies from about 3 to 5 meters in true width. The highest grades of gold occur in the central part of the David Zone, such as 36.28 grams per ton gold over 0.65 meters, or 18.52 grams per ton gold over a meter. Although the deepest hole intersected lower grades of gold, the shear zone and alteration remain strong with a true width of 4.5 meters. Now we know high-grade gold mineralization can be traced down dip for 100 meters and along strike for at least 150 meters. The question is, does the shear zone and mineralization expand at depth or on strike? To help explain what we mean by this, we can look at examples of shear-related gold mineralization elsewhere. This is a cross-section of a relatively new and impressive gold discovery at Wallbridge Mining's Fenelon property in Quebec. Although the age of rocks and gold mineralization at Fenelon are different than the gold shear property, the structural style and type of gold system are somewhat similar. They are both shear-related gold mineralizing events considered to be orogenic type gold systems within sediments and gabbro. What we want to point out is how a change in structure at depth changes the Tabasco Gold Zone. The Tabasco Gold Zone near surface is 15.3 grams per ton gold over 1.2 meters at a depth of about 100 meters. You can see the scale here. Surface 250 meters. When we follow the Tabasco Zone to depth, we see how it expands in size with an impressive intersection of 22.73 grams per ton gold over 48.01 meters. The expansion occurs where the Tabasco Zone structure bends or folds and changes orientation. You can see it here. The bend causes the rocks to come apart and dilate open. This allows more fluid-carrying gold to flow into the area. Dilation in the rocks is occurring in this area at depth. The same thing happens in gold mining camps in Kirkland Lake, Timmins, and elsewhere. The David Zone on the gold shear property has similar gold grades and widths to the Tabasco Zone near surface at 100 meters. What we need to do at the David Zone is discover where the David shear hosting the gold takes a bend, fold, and dilates open on strike or at depth. This is a longitudinal or long section for the David Gold Zone. This long section follows along the shear zone. The previous section was a cross section that cuts across the shear zone. We use the long section to see if there is a preferred orientation to gold mineralization along the shear zone. The colored dots are the locations where drill holes intersect or pierce the David shear. PJX's fence of holes are located here. The other holes are historical holes from the 1990s. This long section is looking west. So north is to the right and south is to the left. The colors represent metal factor, which is a number created by multiplying the gold grade by the intersection's length. For example, an intersection of 10 grams per ton gold over 2 meters has a metal factor of 20. An intersection of 2 grams per ton gold over 10 meters has the same metal factor of 20. This allows us to assess if there is a preferred orientation for gold mineralization by looking at where the most gold is located. Contouring of the metal factor values suggests the gold mineralization has a dip, or what we call plunge to the right, which is to the north along the David shear. You can see the arrows. Additional drilling is needed to the north. This hole down here was drilled by PJX. Although the gold grade was low, the shear zone and alteration remained strong with a good width. Given that this is the only hole at depth, more drilling is required in these areas. We can use geophysics to help assess the geology at depth. You are now looking at an expanded long section, still looking west. The David Gold Zone we showed in the previous slide is a small area near surface, with the arrows showing the possible plunge or dip to the north. The large red target area at depth represents a weakly conductive electromagnetic anomaly. VLF surveys normally only see conductive targets to a depth of about 50 meters. However, Dr. Fred Cook, a geophysicist and retired professor from the University of Calgary, has been experimenting with VLF and using new modeling techniques with the ability to see deeper into the rocks in this region because of the physical characteristics of the rocks. To our surprise, Dr. Cook has identified this large red target area that it has not been tested by drilling. We do not know what is causing the red anomaly. It could be a change in rock type or a fault that may not relate to gold mineralization. However, it could also be related to an increase in conductive sulfide mineralization, or alteration, or a bend or fold in the structure that can be associated with gold mineralization. The shape of the red target is also interesting. This part in the south dips to the north in a similar way to the David Gold Zone and may represent a parallel zone at depth. Additional drilling is required at depth and on strike to test this large target area. This slide compares Wallbridge Mining's long section for the Tabasco Zone on the left to PJX Resources' long section for the David Gold Zone on the right. The sections are approximately the same scale. The gold grades, width, and size of the Tabasco Zone near surface, such as 15.3 grams per ton gold over 1.20 meters, or 11.68 grams per ton gold over 3.16 meters, is similar to the width, size, and grade of the David Gold Zone, with 15.7 grams per ton gold over 1.0 meters and 108.1 grams per ton gold over 0.9 meters. The Tabasco Zone expands at depth to a much larger zone with good grades. For example, 22.73 grams per ton gold over 48.01 meters and 32.18 grams per ton gold over 9.7 meters. These drill hole intersections were shown on the earlier presented slide of the Tabasco cross-section. Where the cross-section cuts across this long section is displayed by this black line. This increase in Tabasco Zone mineralization starts at around 300 to 400 meters deep and continues to depth. The increase in mineralization appears to occur where the Tabasco Zone changes orientation with an apparent bend or fold that dilates and expands the gold zone. This was shown on the cross-section slide for the Tabasco Zone. The next step for PJX is to drill the David Gold Zone at depth and on strike to explore for locations where the David Shear has potential to dilate open and expand in size. Drilling has only scratched the surface at the David Gold Zone. As mentioned, the cause of the large red target area at depth is not known. More drilling is needed to test the David Gold Zone and large red target area at depth and on strike. PJX's 20-kilometer long eddy property is adjacent to and on strike with the David Gold Zone to the north and to the south. Prospecting and mapping have identified bends and folds in the geology with gold mineralization on the eddy property that have not been explored and drilled. What we learned from drilling on the David Gold Zone will help in exploring additional areas on the eddy and other properties. Infrastructure is excellent in the Vulcan Gold Belt. All of PJX Resources properties are road accessible. This photo shows the access road for our Gold Share property and adjacent eddy properties. The crisscrossing power lines are adjacent to the Gold Share property and run along the length of our eddy property. Here's a photo of some of our team standing on the discovery outcrop for the David Gold Zone. We have the Kennedy family of outstanding prospectors, including Craig, Sean, and Mike. Unfortunately, Tom wasn't with us this day. Michael Seabrook, our experienced lead project geologist for gold. PJX director and renowned geologist Dr. Trygve Hoy. And Linda Brennan, who keeps everything running smoothly. Linda is PJX's chief financial officer and is a director and co-founder of the company. PJX trades on the Toronto Venture Exchange with the symbol PJX. We own 100% of the mineral rights to all our properties. We have permits in place to drill the Gold Shear, eddy, and other properties. Our plan is to drill and explore the David Gold Zone at depth and on strike this year, as well as explore priority gold targets on our other properties. In summary, two major structures, the Vulcan Tectonic Zone and the Rocky Mountain Trench, are both associated with gold deposits and gold mining camps in Canada and the United States. The Vulcan Gold Belt is the only place where these two structures intersect one another. Anecdotal data suggests that 1.5 million ounces of placer gold have been mined from the creeks in the Vulcan Gold Belt since gold was first discovered in 1864 and started a gold rush. Potential lode gold deposits that could be the bedrock sources of gold mined from the creeks have not yet been discovered. Our modern understanding of how gold deposits form, such as Telfer, Obuasi, Sukhoi Log, Fort Knox, and others, is better today than in the past. The Vulcan Gold Belt geology fits the model for how these deposits are formed. We, the management of PJX Resources, believe that the Vulcan Gold Belt has the potential to host multiple gold deposits. If you're an investor or a company interested in being involved in what we believe could become a new major gold mining camp, with existing road access, rail, power, and communities that have their roots in mining, then please get in touch with us. We look forward to speaking with you. Thank you for listening to this presentation, and stay healthy.